What if you could configure your entire network with just 3 clicks? SDN is making this possible right now, but 73% of network engineers are still stuck in the CLI dark ages. In this video, I'll show you how SDN controllers are revolutionizing networking with Python and APIs, and why this is the best career opportunity you're not taking advantage of yet. Like the cloud that was the buzzword a few years ago, each service provider has a different opinion on what exactly SDN is and on the different products it offers. Traditional networking uses a distributed model for the control plane. Protocols like ARP, STP, OSPF, EIGRP, and others run separately on each network device. And these network devices communicate with each other, but no central equipment has an overview or controls the entire network. The only exception is on wireless networks, with controllers WLAN. WLC, Wireless LAN Controller. When setting up a wireless network, everything happens on the WLAN controller, which controls and configures the access points. It is no longer necessary to configure each access point separately. Everything is done by the WLAN controller. Well, the principle is the same as with SDN. A central controller is used for the control plane. The SDN controller can be a physical device or even a virtual machine. On the diagram, we can see the SDN controller that is responsible for the control plane. Switches are now just devices, less intelligent, that have only a data plane and no control plane. The SDN controller is responsible for feeding the data plane of these switches with the data from its control plane. So, there are still some advantages and disadvantages to having a distributed control plane compared to a central control plane. One of the advantages of a central controller is that one can configure the entire network from a single device. The central controller has full access and insight into everything that is happening in the network. Here's a new diagram with more detail. Here we can see that the SDN controller uses 2 rather special interfaces: northbound interface, NBI, and southbound interface, SBI. This is what we will detail right away. We'll start with the interface that leads to the south. The SDN controller must communicate with the network devices in order to program the data plane. This is done through the southern interface. So, it's not a physical interface, but a purely software interface, which is often an API, application programming interface. The API is a software interface that allows an application to provide access to other applications using predefined functions and data structures that will be detailed in the rest of the course. We will now detail the 3 types of southern interfaces, the most popular. The OpenFlow is probably the SBI, southbound I interface, the most popular right now. It's a protocol open source of the NFB, Open Networking Foundation. OpenFlow is supported by most network devices and SDN controllers. Then we have Cisco OpFlex, which is Cisco's answer to OpenFlow. It's also an open source protocol which has been submitted to the IETF, Internet Engineering Task Force, to standardize it. And we have the traditional CLI, command line interface. Cisco offers the APIC-EM, Application Policy Infrastructure Controller Enterprise Module, controller, which is an SDN solution for the latest generations of routers and switches. It uses already existing protocols such as Telnet, SSH, and SNMP. Now let's move on to the interface to the north. The north interface is used to access the SDN controller itself. This allows the network admin to access it to configure it or to retrieve information from it. So even if it can be done by a graphical user interface, GUI, There is also an API that allows other applications to access the SDN controller. One can use the API to write scripts and automate network administration. Here are some examples of scripts that can be run. You can list the information of all the equipment on your network. The status of all physical interfaces in the network can be displayed. Add a new VLAN on all switches. View the topology of the entire network. And even automatically configure IP addresses, routing, and ACLs when a new VM is created. And here is a diagram that shows the different possibilities to access the SDN controller. Through the API, several applications can access the SDN controller. A user can use a GUI to retrieve network information from the SDN controller. In real life, the GUI uses the API. Scripts written in Java or Python can also use the API to retrieve information from the SDN controller or even to configure the network directly. And other applications can also access the SDN controller. For example, it can be an application that automatically configures the network as soon as a new virtual machine is created on a VMware ESXi server. API REST. We have seen that the north and south interfaces use API, Application Programming Interface. We will now take a closer look at what an API is. SDN controllers typically use an Application Programming Interface, Representational State Transfer, REST, API, which allows HTTP messages to be used to send and receive information between the SDN controller and another application. These are the same HTTP messages that are used when browsing a web page on the internet or entering a contact form. For example, HTTP GET is used when we want to retrieve information. An HTTP POST or HTTP PUT is used when we want to submit or update information. The REST API works as if you were browsing a web page, except that here you don't ask to display a page or an image, but rather a particular object of the SDN controller. For example, it can be to list all the VLANs in the network. When the SDN controller receives a HTTP GET request, it responds with a HTTP GET reply containing the requested information, and this information is provided in a specific data format. The two most commonly used data formats are JSON, JavaScript Object Notation, and XML, Extensible Markup Language. Here's an example to visualize the process. Here, we have a Python script that uses HTTP GET to retrieve a URL via the API. This URL is used to retrieve certain variables, such as information about the hosts on the network. And once the API receives this request, it will respond with an HTTP GET response. The requested variables will be provided in JSON format. Even if we have never seen JSON, we can still quite easily understand the output. For example, here, the result returns us two hosts with their IP addresses and MAC addresses. The future of the traditional network. I hope this course has given you a better understanding of what SDN is and why today's market is very favorable to it, compared to the benefit it can give. Time will tell what the network will look like in the future. It is very likely that in the near future, we will use the API more often than the CLI. So, should network admins be worried about programming coming into the network? Well, I don't think so. Because a programmer can be very good in programming languages, such as C++, Java, or Python, but he will necessarily need knowledge of networking. On the other hand, network admins will have to learn to use a programming language to execute some basic scripts, but without necessarily learning to develop a complete application from scratch. That's more the role of the programmer. So, it would be a good idea to spend some time learning a language like Python and using APIs. At the moment, we don't know how much SDN will develop, but this scenario reminds me a bit of what happened to analog telephony. There are many telephony veterans who refuse to learn how VoIP works, thinking that it was impossible to replace traditional telephony. Today, these telephony veterans have become a little outdated in a world dominated by VoIP. For my part, a former telephone operator, it is thanks to the arrival of this new technology which put me on the path to Cisco certification and made me discover the wonderful world of the network.